So I'm going to speak English. Everybody capable of understanding that language? Wer versteht kein Englisch? Gut. Who doesn't understand? Okay. If you understand English, then who understands English? Great. So you actually are awake and you're hearing me talk. That's cool. So my name is Toby Oettiker. I'm going to be your presenter teacher for this morning in the RRDtool workshop. We're going to do two things mainly. I'm going to do a little performance up here explaining to you how RRDtool works and how you can do graphs and stuff. And then I also have a rather long series of exercises you can solve to also learn RRDtool. Both items could take the whole time, but they can't happen at the same time. So I'll try to adjust depending on your involvement, how many questions you ask, and how well it goes. Also, if you're bored, you could start solving the exercises while I'm talking. All the stuff I'm going to present today is on here. Can you read that in the back? Probably not. I'm going to copy that. I brought the .3 version of the exercises. You can pass that around. It's 8 sheets, or rather, if they're double-sided, it's 4 sheets, and otherwise it's 8 sheets. So on these workstations, there's an installation which is local, and it may be destroyed. So you have root access if you want to using sudo. So if something's missing or should be changed, you can change it. RRDtool is installed. So if you do the exercises, you can do that on that workstation, or you can use your laptop if you want. We'll see how that goes. And whenever you have questions, just ask them, and I'll try to answer. So RRDtool, I'm going to sort of start from the beginning. RRDtool is a database. It's called round robin database. Most people these days associate databases with either something SQL-like, MySQL, or PostgreSQL, or SQL Server, or if they're very hip, they think of a NoSQL database. And then there are also other databases, like BerkeleyDB or round robin database. The main motivation for creating another database was that I wanted to store time series data. While all the other databases are geared towards storing any data, RRDtool is very narrow-minded. It can only store time series data. But then again, because it limits itself to this topic, it can do some stuff to the data which other databases wouldn't dare to. And the main thing RRDtool does to the data is that it doesn't store the data you hand to it, but rather it resamples the data for you and then stores the resampled version of the data. And that's sort of the core thing RRDtool does, which might, or sometimes frightens people when they discover it. So you have that system, OpenNMS, for example, which goes out to your devices and gathers information about the traffic on your router or the temperature in your server room. And it does that on a schedule, right? It goes there every 5 minutes or every 2 minutes to pull that data. Now, in reality, you won't make it exactly every 5 minutes, because there'll be delays. Sometimes a device doesn't respond as quickly as it should. A query might even be lost on the network and not happen, so it has to be retried. The effect is that data arrives roughly every 5 minutes, but not exactly. And so what RRDtool does is it takes this data and knows that you intended to store one data point every 5 minutes. So it takes the actual arrival time of the data and then integrates the space underneath this curve, which is built by all the arrival times of the data, and creates new points in time which fit to that interval you set when you created the database. And that new data represents the same space underneath the curve as the original curve. So this means if you're accounting for traffic, the amount of traffic represented by the newly resampled data points will be exactly the same amount of traffic which is represented by the original data points. But if you look at the numbers will be different. The numbers stored in the database, because if your data point was sampled at 3 minutes past the hour, but you're storing one sample every 5 minutes, then the storing will happen at the hour and 5 minutes past the hour and 10 minutes past the hour. So that sample which is arriving at 3 minutes past the hour can't go into the database. So it has to be readjusted into the right slots. And that, while it does that readjustment, it also changes the value so that the new value still represents the same space underneath the curve. I have some images on that. Different talk. Okay, so in this talk, I'll go to code rather quickly. So you'll always see how things are done. And as we were talking about RRDtool, the database, we have to create one. Otherwise, we can't store data anywhere. So when you create a database in a SQL world, you have to tell the SQL database what columns you want, what type of data you want to store in each column, stuff like that, which tables. In RRDtool, each table, as such, is stored in a separate file. So a file represents one table. Each table can contain multiple columns if you want to. So this little script here is done so that it would use RRDtool from a different installation. The idea here is that if you compile your own copy of the code, that you could experiment with that. But if you don't have it installed here, then it would just use the normal version of RRDtool. By the way, all these scripts, you can find them also on this website address I gave earlier. They're stored in a subdirectory there so that you can try them out. So what this does is it creates an RD database. And that RD database is called first RD. And the database has a base interval of 300 seconds. This means RRDtool will resample all the data you feed into that database to a 300-second interval. You can feed data as quickly as you want in 1-second intervals if you like to, but the data will get resampled to 300 seconds on storage. So it'll only store things every 300 seconds. But it'll take all the input you give to RRDtool into account. It'll just not be stored individually. And I also tell RRDtool when it should start a database. So that's the first point in time when RRDtool will accept data into this database. If you try to store data earlier, RRDtool will tell you, no, sorry, I'm already ahead of you. You can't update me anymore. Due to this resampling of the data, RRDtool doesn't accept data from the past. So whenever you input new data, it'll take the last data it saw and your new data and then fill in the gap between those 2 points. And when you later on try to feed him something from earlier in time, it'll say, no, sorry, I'm already here. You can't go back in time. Now, the next element, sorry, fighting with the browser here. The next element on the command line is the data source. So that is equivalent to a column in a SQL database. The data source represents where I'm getting my data from. And I'm telling RRDtool something about the nature of the data I'm going to store. Now, it's always time series data, and it's always floating point data. So the data type internally is always the same. But by defining a data source, you can give RRDtool some information about the nature of the data. So what I'm doing here is I'm telling it that it's going to be called temperature. So whenever I refer to that data, to that column, I can refer to it by name, and the name is temperature. And then I'm also telling it that it's gauge type data. So that means a thermometer always gives me a number which stands alone. So if I read the thermometer every 2 seconds or every 5 minutes, I always get a temperature. And it doesn't matter what the last temperature was. It's just always a piece of information which stands on its own. Whereas if I'm looking at the router and I'm reading the traffic of a router interface, it doesn't tell me I'm running at 10 megabit per second at the moment. It tells me, oh, I transported 700,532 bits or octets. And then when I ask it next time, it tells me I transported 800,763 octets. And then I have to know what it told me last time and build the difference between these two readings in order to figure out how fast it was in doing that. And RRDtool can do that for me if I tell him that the data source is not gauge, it's counter. So by telling RRDtool that it's a counter data source, it'll know that every time I'm feeding it a number, it has to build the difference between the last feeding, the last number, and the next. And then take the time into account in order to arrive at the rate of data transmission. I can also tell RRDtool how often I insist on updating this data source. So what we have here is that I tell RRDtool I only accept data if it's arriving within 600 seconds of the last update. So while the RRDtool database is running at 300-second intervals, so it will store something every 300 seconds, 2 consecutive readings from the outside world may be up to 600 seconds apart. If they're further apart, then RRDtool says, sorry, that data is not good anymore. I can't reliably build the difference between those two readings because something may have happened in between and I can't build the difference anymore. Well, obviously, it could calculate the difference, but the confidence in its validity is too low. So by setting that, RRDtool will automatically reject any input which arrives more than 600 seconds after the last input. It'll do that silently. So all these rules you define for the data source, they'll be applied, but RRDtool will not complain if you try to input data which does not comply with these rules. So you won't get flooded with error messages or anything. It'll just store an unknown value in its database.
How does it work in combination with counter? So you will take the next step, then make the difference between, let's say, 10 minutes for the value and divides through the 10 minutes?
So if You mean if it's more than 10 minutes or if it's less than 10 minutes?
You get a number now.
Yes.
Then you would get a number in 5 minutes.
Mm-hmm.
And if the number isn't stored.
So I get one number now.
Of 10 minutes, then you get no value.
It will get stored. If I pull a number now and then another one in 5 minutes, then RRDtool will build the difference between those two numbers and the difference between the timestamps and calculate the rate and store that.
But if I didn't get the number
at 5 minutes,
10 minutes.
Well, that's in the future. The point is, if you get one now and then you don't get one for 10 minutes and you get one at 11 minutes and you give it to RRDtool, then it says, oh, it's more than 10 minutes since the last update. We'll say, okay, so for those 10 minutes, I don't know what the traffic was and stores unknown in this range of time.
That's what I mean. Calculates the difference.
It calculates the difference and it says, it's no good. Can't do anything with it because you told him that it has to stop at 10 minutes. So if you're past 10 minutes with your update, it'll refuse it and not store data. And it'll not store 0, it'll store unknown, which is different. So we'll get into that some more. It knows about the difference between 0 and unknown, sort of similar to a SQL database which knows about null and an empty string or 0. Those are 3 different things. And unknown is very special properties, as we'll see. The last 2 items when I'm defining a data source are for setting a lower and upper boundary for the data, for the rate in this case. So if I know that my router interface can transport between 0 and 1 gigabyte or 1 gigabit of data, so I'd set my limits to 0 to 1 gigabit divided by 8, because it's octets on the router interface, not bits. And then RRDtool will make sure that the data which is coming in actually complies with these rules. And if it's outside, it'll again store unknown. Or if I'm looking at the temperature, as in this example, I set it to -40, between -40 and 100. So I can be sure, or I'm pretty sure that in my server room, the temperature will never be under -40 degrees Celsius and over 100 degrees Celsius. I might even narrow it down a little, but that's just sort of safety margins. If it's outside that, then maybe my temperature sensor has gone haywire, and I don't want to store that data in my database because it will cause spikes and scaling will fall apart. So I'd rather store unknown. Now, with the data source defined, RRDtool is now able to receive data. I haven't told RRDtool yet how I want it stored. I told it that I want to resample the data at 300-second intervals, but nothing about storing. The database is called round-robin database for a reason. And the reason is that it doesn't store data as normal databases do sequentially into an ever-growing file or file structure. RRDtool sets up a file as you create the database, and that file already has enough space to store all the data you ever want to store in that database. And this space for storing data is called a round-robin archive. You can actually have several of those round-robin archives, and the round-robin archives have the special property of jumping back to their beginning when you reach the end. So you set up an archive and tell RRDtool, I want an archive which stores my 5-minute data for a day. So RRDtool calculates how much space it needs for that and allocates that space in a file. And then every 5 minutes you can store one item into that archive, and when it's at the end of the day, it jumps to the beginning and starts overwriting the old items in the archive. Very simple. So what I'm doing here, I'm telling RRDtool that I'm storing on every round, so every 5 minutes, one item, and I'm doing that for 5 entries. So it's a very small round-robin archive I'm creating here. It will only store 5 times 5 minutes worth of data, so 25 minutes worth of data. And this guy here, 0.4, says that at least 0.4 or 40% of the data has to be valid in order to go into the archive. And that's where the unknown comes into play. So if you're storing data into RRDtool and part of the data is unknown, RRDtool will track that amount of unknownness of your data and will only store data if a certain amount of the data is valid and known. Otherwise, it will store unknown into the archive. Now, if you're sampling your data every minute, and you do that on a lot of devices, you're bound to assemble a lot of data. And your disks will fill. Or if you're using RRDtool, even creating the data stores for that data will already fill your disks. So the question is, how long do you want to keep the data, that 1 minute data? Yeah, RRDtool makes you decide at creation time for how long you want to store that data. And oftentimes, those systems which use RRDtool decide for you. They may offer an option for changing that, but oftentimes there's some defaults. I don't know. How is it with OpenNMS? Does anyone know? OpenNMS uses RRDtool, I know. And somehow it configures it to store the data. And
you almost never have to look into the data. They have some reasonable defaults.
So, but you might want to look at that after this presentation. So, if you have people at your site who come to you and tell you, in December we had that network problem. Let's look at December 12th morning between 10 and 10:15. How was the traffic on that router? Have you ever tried that with OpenNMS? And what does show on the screen? Does it work? And if they come to you and tell you, I need to know from December 2011 between 11:13 and 12:30. Does it also work?
It's also possible because you don't have one value, you have aggregated values.
Okay, but then they want to see the spikes.
Yes.
The spikes are gone in December 2011, right? Because it's just sort of blocky data. And so that's RRDtool doing that. And the way RRDtool copes with the huge amount of data you could, or you're collecting, is that it allows you to consolidate the data as it gets older. And you're doing that by creating those round-robin archives. So my first guy here actually stores every sample. Every 300 seconds, it stores one sample in its archive. The second archive stores one sample every 3 samples. And it does that for 2 samples. So it's a very short guy. It's consolidating 3 samples into one and then storing it. And that's why if you're looking at 2011, you may still have data, but it's actually in large blocks. Whereas if you're looking at December 2012, you still have the high resolution data. And you can tune that. And there is no performance penalty in storing data, even if you set up an archive which covers 10 years at 5-second intervals. It's fine if you have the disk space. And you may need a 64-bit machine to actually address the large file, but RRDtool will be fine with that. The problem is then if you want to generate a graph covering the 10 years and you have only stored 1-minute intervals in that huge RD round-robin archive, then RRDtool would have to read in the 10 years and bunch the data up into one graph, which might take some time because the file might be rather large. Although it's surprisingly small. You can do the math or even try to create one, which holds really a lot of data. But anyway, what you can do is you create a second round-robin archive at the lower resolution. So as RRDtool is updating its internal data structures, it will continually also update a consolidated version of the data. So when you're painting a graph for 10 years, it will not pick the data from that 1-minute interval. It will rather go to the other archive, which stores data in 1-day intervals, thus saving a lot of calculation time. So it will be a factor of 100 faster or so. And you can really decide here how that data structure should be. And there's some default data structure in OpenNMS, but depending on your site's requirements, you might want to change that default data structure. It's really just a matter of disk space. Later on, yes. But you obviously, if you create hundreds of round-robin archives in one RD file, then I/O performance for updating will also suffer because it has to update all those different round-robin archives. But if you create one round-robin archive which only updates once a day, because it stores only daily averages, then this penalty will only happen once a day. So it's not really costly. Except at midnight, when all those guys get updated, then your server might get a little bit of a hit. But then nobody's looking at the data at midnight in Europe. It's Greenwich Mean Time, midnight, always. And as RRDtool archives are consolidating data into, or several samples into one slot in the archive, you have to tell them, or you can tell them, how they should consolidate the data. And there's different consolidation functions available. The most common one is probably average, but you could also use the min or the max function to keep the minimum value or the maximum value, which can also be interesting if you're looking at cases where you want to guarantee certain round trip times, for example. Then you're not interested in the average round trip time, but you're interested in the maximum round trip time. Because even if you have one outlier, you might not want to have that. If you're working for a stockbroker, for example, they're very sensitive to latencies, or for a gaming outfit, then you might want to track your maximum latencies and not some average latencies. Now, maximum here means maximum 300-second average. RRDtool will always average your actual data into those 300-second intervals. So even if you had one outlier within a 300-second interval, you would get the average for the 300 seconds. So if you need to know stuff at the higher resolution, you can do that. You can tell RRDtool to set its step size to 10 seconds, for example. You could still store averages for 5 minutes by picking a higher number here and having RRDtool to average those base steps into already aggregated samples which get stored in the into the RA. But then the max would pick the highest 10-second interval. So as you're creating the RD file, there are already a lot of decisions you're taking regarding the type of information you can then later on get back from your RD file. Once you've created an RD file, you can feed it data. It's very simple. You basically say RRDtool update and the name of the RD file, and then something like this. So that's a timestamp, a Unix timestamp. The Unix timestamp is the number of seconds since 1970. You just have to know. And then you give it that number. Obviously, your programming language will tell you. And you also give it the number to use for the update. And that's the number you read from the data source, from the original data source. So it could be the temperature in your server room or the counter you acquired from your router using SNMP. That point in time when you did the acquisition of the data is very important. Because RRDtool will use it to resample the data into its rigid step interval. And if you were not giving RRDtool information about when you acquired the data, then there will be jitter as the data is maybe shifting a little due to processing happening between the point in time when you acquire the data and when you actually feed it to RRDtool. OpenNMS has an engine which is able to decouple the acquisition of the data and the feeding to RRDtool, as far as I know. So it's very important in OpenNMS that it stores the acquisition time of the data and doesn't update RRDtool just by telling it, yeah, use the current time for the update. Because what you could do, if you were really simple, you could replace that long number here with the letter N. N meaning now. And then it would take the clock from your computer and just use that for the timestamp. Incidentally, you could even use high precision time in milliseconds here. So you can put a comma and the number of milliseconds after the number of seconds. People doing satellite tracking, for example, seem to work in milliseconds to prevent the jitter in their tracking of the satellite's position. And some guy, from where he was, he contributed a patch to RRDtool to make it aware of sub-second precision information. And therefore, you can now input microseconds, milliseconds. Now, RRDtool stores its data as a binary file. If you ever looked at the file using an editor or less, you'll notice that it's not human readable. But what you can do if you want to look into the file is you can look at an XML representation of the file. RRDtool has a dump function which lets you dump the RD file into an XML structure. And that's how this structure looks like. And that's really all the information which is stored in the RD file. And there you can see that all the things you defined when you set up the data store are represented here. So there's a step value, there's the name of the data source, the type of the data source, the minimum required heartbeat, and so on. There's also something called last update. Whenever you update the RD database, RRDtool will store the point in time when you updated the database, so that when you update it next time, it can use that information to calculate the time difference between the two updates, and if it's counters, use that to calculate the rate between those two updates. A round-robin archive has two parts of information. In the first part, the preparation area, it'll store information prior to actually updating the round-robin archive. So let's assume you have a round-robin archive which stores data only once a day, because it should store daily averages. How do the averages actually get created before they're put into the round-robin archive? And the way that happens is that each round-robin archive has an associated preparation area in the round-robin database, where the data is being built up up to the point in time when the round-robin archive should be updated. So each round-robin archive lives on its own. It's not dependent on data in any of the other round-robin archives. It has its own preparation area where the data is being fed and stored and prepared. And once it's ready, one item is transferred to the long-term storage. The location of these data storage areas within the file is done so that there is a header part at the beginning where the static information is stored. So all the information about the structure of the database is stored at the beginning, followed by a live head. That's the area where all the data preparation is happening. So for all the round-robin archives, data preparation areas are stored in that location, and also the location where the data is being resampled into those base intervals you set up for the database, meaning that as you're updating the round-robin database, only this part, this very beginning of the database, has to be touched. The long round-robin archives may be holding 1 year or 10 years worth of data, which could be huge on disks, are not actually accessed until data has to be written into one of those archives. And even when data has to be written into the archives, then only those bytes which have to go to disks are sent to this location. Meaning that on a performance side, the blocks which have to be read from disk in order to be updated, they're closely together for most of the operations. So it's basically the beginning of the file which has to be touched every time. And the rest of the file only has to be touched when the round-robin archives actually get modified. So to recap, RRDtool is a database, like many others, except that RRDtool is optimized for time series data. It doesn't store text or your address data. It only stores time series data. And it does nasty things to the data. It doesn't store what you feed it. It stores the essence of the data. And you can define how that consolidation has to happen and how it arrives at the essence. It does that by creating multiple fixed-sized rotating data stores, meaning an RD file, as you create it, already has its final size. You feed data to it, it gets stored into different locations, pointers pointing to the right location within the rotating buffer, and every time you update it, it goes down one, and when it's at the end, it jumps to the beginning and starts overwriting the old entries. It happens all automatically, but there's a big advantage. Once you've set up a system using RRDtool, all disk space it's ever going to need is already allocated. You can leave it running. It will never run out of disk space. Even when someone else is filling the disk and the disk is completely full, RRDtool will happily continue to run because it doesn't create any temporary files or anything. It just stores data in its pre-allocated space. Also, RRDtool does all its consolidation on the fly, meaning there is no data vacuuming or database consolidation runs you have to do. For SQL databases, they tend to deteriorate over time. And depending on the product you're using, there is functions within the SQL language, like, for example, PostgreSQL has a vacuum command, which lets it sort of take the fluff of its tables and reclaim space. But even vacuuming a database is not as good as dumping the database and restoring the whole database, which is the only way to actually clean it properly. RRDtool doesn't need that. RRDtool, the database does not deteriorate in any way. You can update it for years. It'll always be in the same high quality, pristine, original standard as it was in the initial creation. And the reason for this is that RRDtool puts those strong or hard rules on its data. It doesn't store your data. It stores its own version of the data by resampling your data. So that's the price you pay for the stability, but it's hands-off afterwards. And I think that's a big win for a system which should run for a large operation without hand-holding. Here. Okay, and here's an example of what happens when data is arriving at irregular intervals. So that database, and as I said, that code is all available on the website if you want to try it out. So we're creating a database at the 300-second interval. And now these updates we're feeding, they're not at 300-second intervals. They're actually at sort of on the hour, and then 150 seconds later, 310 seconds later, 640 seconds later, and 910 seconds later. Rather irregular, but who knows? Could happen. So this data here has an interesting property. I'm always feeding the same number as the last part of the time. So what curve would be created by that data?
Straight line.
A straight line, right? It's a very simple curve, just a straight line going up. Because the point in time correlates with the number I'm feeding it. And I'm doing that to test what RRDtool does with that data. Because the points at 300 seconds interval, they should again be on that line, giving you the equal numbers. Okay, let's go back a little. So here I'm using a counter, right? So it's not actually a line like this. It's a line like this. Because the rate of increase between two consecutive readings is always the number of seconds that has passed. So the rate is actually horizontal. It's always the same rate. And the rate is 1, or rather 0.1. So I'm doing all these updates. And then there's a command called RRDtool fetch, which lets me pull data off the round-robin archives and have it displayed. When fetching, I have to tell RRDtool when it should start, when it should stop, and what consolidation function it should use for the fetching. By specifying the consolidation function, RRDtool will only look at the round-robin archives of that consolidation function. And then it pulls the data. The 300-second intervals, which get chosen here, they're because the default interval in a fetch operation is 300 seconds. You could change the interval, and then it would try to pick data at the different interval from the round-robin archives. But it'll always give you data which covers, or data from a round-robin archive, which is actually covering that range here at the best resolution available, higher than the resolution you specified. This makes it sort of resilient. If you're going for a 1-minute resolution 2 years back, but there's no round-robin archive available which actually covers that resolution, then it'll just pick a lower resolution back then. But as you go closer to the present, suddenly there is an RRA with the proper resolution, and then it'll go to that higher resolution RRA and give you that data. And that's what's happening when you're working with an interactive graph display where you can move around in time and suddenly the data goes blocky. Round-robin, the graph instructions don't have to know about the fact that the round-robin archives are available or not. They'll just, by using that fetch function internally, it'll just fall through to another round-robin archive which actually has data for that point in time, although it doesn't have that data at the highest resolution. And as you can see here, the data which ended up in the round-robin archive is that 0.1 as expected, so a straight horizontal line, meaning that the data rate, even though those measurements were all over the time space, didn't matter. RRDtool reached the right conclusion and stored at quite a high precision that data which represents the rate of traffic in that line. So if you do billing using this, you're perfectly fine. And that was one of the reasons for the design of RRDtool to be so vigilant about time. There is a competitor out there. It's called Graphite. Who knows Graphite? It's very cool. It has that great graphical interface. It lets you update data in the past. You can just open a socket on the web and send it data, and it stores it, automatically can create new databases on the fly. You just give it data for a non-existing database, and it'll pop one up for you. It's very user-friendly. Although the guys creating Graphite don't seem to have such a high regard for data precision. It might have changed, but when I looked at the system, what they were doing was not that they were resampling the data. They were just looking at, okay, the data has arrived in that time interval. It's the data for that time interval in that case. So if you're looking at 5-minute intervals and you feed it data, it says, oh, it's 7 past the hour. Okay, it goes into the 10 past interval slot and update the database with that data. And then you immediately send it another update, and it looks at its watch and says, oh, it's 8 minutes past the hour. Okay, again, in the 10 minutes past the hour slot, overwriting your previous update, which makes it very convenient because you can also go back in time and okay, it's 5 minutes before the hour. Okay, update that slot. But precision, no. So it's more a tool for getting, for looking at performance and stuff like that. But if you do billing, you probably shouldn't use Graphite. Or if you want to actually see the real data, Graphite might not be ideal. But it's very user-friendly. It has a really great web interface. RRDtool web interfaces could learn a lot from Graphite. Just don't believe the stuff they write about RRDtool. They have an RRDtool section on their website where they're bashing RRDtool about not being able to do stuff, which is totally not true. I have no idea. They never talked to me. I don't know how they arrived at those conclusions.
What about your interval and your last data point? The interval ends at 899, and the last data point is from 900.
Yes. So there's a sort of a metaphysical problem with bins. So the bins end, they're always on the dot. So it's at on the hour, 5 minutes past the hour, 10 minutes past the hour, 15 minutes past the hour. So the timestamp on that data storage bin is 5 minutes past 9. But what data does it represent? Because the rate is not valid for a point in time. The rate is valid for an interval of time. You agree? So now, when I'm storing that information at 5 minutes past the hour, what interval should it be valid for? Now, you can say it should be valid for the time between 5 minutes and 10 minutes past the hour, sort of for the next interval. I'm telling you at 5 minutes past the hour for what the data should be for the next 5 minutes, except that 5 minutes past the hour, I don't know what the data will be because it hasn't happened yet. So I can't store it now. So I decided to always store past the fact. So after I've acquired the data, I'm going to store it. Now, the other question is the data for 5 minutes past the hour still within, or is the 5-minute tick sort of, is that still within the interval, or is it just past the interval and already past part of the next interval? And there, the idea was that there is some time required to process the data and store the data. So it can't really be that at 5 minutes past the hour, I already know the data for 5 minutes, for that exact point in time. So actually, it's sort of a micro, nano, femto, attosecond before the 5 minutes when it ends. And at 5 minutes, everything is prepared and stored. And so by asking it for data until 899, I'm telling it, yeah, I know. If I ask you for until 900, then you'll give me the next interval, because 900 is definitely already part of the next interval. Okay? Makes your brain hurt. But you have to think about this once, and once you've understood it, it sort of works. Yes?
This fetch command, does it literally execute that at the command line and then we'll get a tabular list like you
Yes.
presented here? Is that simple? What if you were, can you do like multiple ranges within one command line? Like if you wanted to do 20, you wanted a 5-minute or 15-minute window, but you wanted to go back over the last 7 days for that same time frame.
Each day.
Each day, 20
Then you have to
hours.
execute five
Five of those lines.
of those lines. There's a performance penalty when you do that, because it has to. There's a performance penalty when you do that, because you have to start up RRDtool every time, which for fetch won't make such a big difference, because RRDtool will be cached by the OS, and therefore starting it up will not make much of a difference. But if you're using RRDtool Graph, for example, then it uses the font config font system to pull in fonts. And font config does lots of caching of font information to optimize its performance. So if you're creating a graph and you have some writing in the graph, RRDtool will employ font config and Pango and all those other libraries to actually do the font, the writing. And as it's doing that for the first time, all sorts of caching will happen. And then RRDtool ends and all the caches go empty again, and you start RRDtool again for the next graph, and then it does all the caching again and would be ready to do another graph, except there's no way on the command line to do another graph, and so everything's lost again. On the other hand, if you're using RRDtool from a scripting language where it's loaded as a shared library, then first graph will take some time to do all the caching, and then the next graph will be much faster because all the caching has already happened. Now, if you're on the command line, obviously you're sort of in a bind. You can't do that. But there is a way out. What you can do is you can start RRDtool with just a dash as its argument. And then it'll go into pipe mode. And I don't know, there is a Java implementation of controlling RRDtool through pipe mode done by Peter Stamfest from Austria. I don't think it's widely publicized, but he posted about it on the RRDtool website mailing list, I think a year back or so. He's on Facebook, so if you're interested in that, you can reach him. Anyway, the way the pipe mode works is that RRDtool acts as a little server, receiving just commands. So you can give it command line instructions like this, but it'll keep running. So you give it the command line, and then new line, and then it'll execute that and do whatever, create a graph or spit out that information, and then wait for the next command. And so by hooking it up with a pipe and receiving its output on standard out and sending it new instructions over standard in, you can keep it running and therefore use all the caching and other optimizations which happen when you execute multiple commands in sequence. On the command line, if you're just writing a script, You could also use that by writing your instructions into a temporary file and then piping the file into RRDtool minus. And then it will also execute all those commands. There's some shells which have a command line limitation. They don't allow you to do really long command lines. And then when you have a complex graph instructions, they would fail. RRDtool in pipe mode doesn't have any restrictions on the command line length. So you could have a 100 kilobyte of command line, single line instruction for a graph, and that would be all right. Okay. So with that knowledge about RRDtool structure, you can optimize your round-robin databases. When you update the round-robin database, it has to open a file and then do some calculations and then write blocks to disk, and then it closes the file again. Now, writing blocks of data to disk is costly. Therefore, you might want not to do that or minimize doing that. One way of minimizing that is having multiple data sources in one round-robin database. So multiple columns in your database. Can be done, no problem. You can have multiple DS instructions when you create your database, and then RRDtool will store those next to each other. But if you do that, then on every update, you have to give RRDtool data for all those data sources which are stored in the same round-robin database. So that is only suitable for data sources which you acquire at the same time. So if you have that sensor in your server room which measures the temperature and the humidity and I know the amount of smoke, whatever, and you always get those three types of data at the same time, then you could also create a round-robin database which stores those three guys at the same time, because you're always acquiring them at the same time. So they have the same timestamp. Then whenever you do an update, you update all three. And it will be almost as fast as if you updated only one. But you have to know that they have to arrive at the same point in time. But for routers as well, routers have all those huge number of counters in there, and you can acquire many counters at the same point in time. And so you could create rather large RD files from a router. If you're not so sure that things belong together, then you shouldn't store them in one RD file, because there are not any good tools in the basic RD setup which let you reconfigure an RD file. So you have to make the right decision at the start and go with it. Obviously, you could use RRDtool dump and then modify the XML and do an RRDtool restore from the XML to create a new version of the RD file. There is actually a tool out there which I wrote. It's called RRDchig, which lets you feed a new RD file with data from an old RD file, allowing you to modify the whole structure of the RD file. And then the data gets re-entered as if it was created in the first instance. Also, to repeat, the size of the RD file, so the length of those round-robin archives doesn't have any impact on the update performance. So whether you store 1 second intervals for 10 years or 1 second intervals for 5 days, the update doesn't take a different amount of time. You're working on a question? No?
Just thinking.
Okay, good. if you have many round-robin archives on the other hand. And RRDtool doesn't have to update only one, but 4 every time it does an update, then those 4 round-robin archives will be stored sequentially on disk, and the disk head has to move to 4 different locations to update those round-robin archives. So that will affect performance.
I have a question. How compressible is an RRD file?
That depends on your data. If you have data which is always the same, like in my example where it's always 1, then it will be very compressible. But if it's really random data, then it will not be compressible at all. There is no, okay, the RRD file format is very compact. There is no space in there, except like if you have always integer numbers, then their binary representation in a 8-byte double will be similar. So there might be some way to compress that, but there is no empty space in that data structure. It's really just there. And if you fill it with random data, I don't think you can compress it. You can compress it a lot.
Yeah, I was thinking about persistent support.
Like CFS, for example. Although I wonder, I haven't tried it on CFS because CFS always storing, doing its copy on write. I don't know how well that deals with RRDtool updates because the data will get very fragmented somehow, I guess, by CFS method. I haven't tried it. I don't know how it performs long term. Okay, there is another in-depth view on that fetching. So we'll have another look. So I'm creating an RRD file which has 2 round-robin archives. One has 2 entries at 300 seconds, and the second one is storing 1 entry every 2 intervals. So it's a 600-second interval in the second and a 300-second interval in the first. So first, I'm pulling data for the 300-second interval. And here you can see the range I'm specifying. And now I'm specifying that I want data starting at 600 seconds and ending at 900. And since 900 is not part of the first interval, I get a second reading, except that I won't really use that second guy, but the 900 point is already part of the next interval. And then the second request is to get a longer period of data. Now, the longer period of data is not covered by my high-resolution round-robin archive, because the first round-robin archive, this guy here, only stores 2 data points at 300 seconds. So it will end at 600 seconds. It's very short, right? It has only 2 storage spaces. Whereas the second round-robin archive has 3 storage spaces 600 seconds apart. So if I'm fetching for 900 seconds, then only the low-resolution round-robin archive can cover that amount of time. And as you can see, RRDtool will give me the data, but it's coming not from my intended 300-second resolution round-robin archive, but from the lower resolution round-robin archive. There used to be a peculiarity in RRDtool that it made sure that the data range was completely covered by the round-robin archive it picked its data from. And it didn't only look at the time in the past, it also looked at the time in the present. And so if you had a setup where those round-robin archives didn't align at the point in the present, then it could happen that if you asked RRDtool fetch to fetch data from now to, I don't know, half an hour in the past, that you would get data from a low-resolution round-robin archive because that was already updated, whereas the high-resolution archive was not yet updated because the half-hour interval of the low-resolution was better than the 3-minute interval or the 4-minute interval of the high-resolution archive. Can you imagine how that works? Can we do can I paint on that? Can we switch that on? Or is that's too much of a, right? No. Okay, forget it. Forget it. No. I'll paint on the blackboard. So there's one round-robin archive storing data every 30 minutes. And there's a second one storing data every 4 minutes. Okay? Now, that's the past. That's when they started. And now they're getting updated. Okay, so, and now we're here. That's the present. And as you can see, the 30-minute interval already has happened. And so this guy here has been updated, whereas the 4-minute interval hasn't happened yet. And so this high-resolution archive hasn't been updated yet. It'll only be updated in the future. So if I'm asking fetch now to give me data for that interval, there would be very sensible data available, but I won't get it because that guy is not actually covering the whole of my request, which is stupid, right? So I realized that after about 8 years. And so if you're using a recent version of RRDtool, it doesn't look at the present because all the round-robin archives will do their best to be updated at the present point in time. It'll only look at the past. But if you have an old version of RRDtool and the system which you're using is not taking this into account, it may happen that when you're looking at graphs, that suddenly they go into block mode, even though you know that there is a high-resolution version of the data available, but for some reason the graph is displaying blocky data from some low-resolution round-robin archive. And that's the reason why this is happening, or used to happen in older versions of RRDtool. Presently, it just disregards this part of your request when it picks. So the endpoint in time is disregarded when picking the right round-robin archive. So in 1.3, that endpoint requirement was dropped. You can also ask RRDtool fetch to fetch data which is outside the covered time range. And it'll comply, no problem, except that all the data you get is unknown. And unknown data is represented by nan, not a number. So your chart, if you're drawing a chart, will just be empty. And if you're doing fetch on the command line, you get nan on each timestamp because there is no data available. Any questions on the database structure? Oh, okay. We have still 15 minutes to go to the break, so I'll launch into graphing. Creating charts with RRDtool is, for some people, the only reason they're using RRDtool. They don't actually store the data in RRDtool. They create RD files on the fly out of a database, and then use RDgraph to create a graph. That happens. Someone contributed bindings for SQL, for DBI drivers to RRDtool. So if you're using RRDtool 1.4, you can compile it so that it can access data from a SQL database directly and do all the resampling on the fly and then paint your graphs. So if you're just interested in graphing, there are better ways than creating an RD file and then doing the graph. RRDtool graph instructions are maybe the longest command line things you can see in the Unix world. And before we look at details, let me give you the idea or the design idea behind the command line language of RDgraph. There are two kinds of instructions. There are options. They start with 2 dashes or 1 dash if there's a short name. And they can be placed anywhere on the command line, and they affect the whole operation of RDgraph. So they modify the graph size, for example. They modify the color of some component of the graph. They define when the graph should start, when it should end, stuff like that. And then there are instructions which do things to the graph. So there's the line instruction, which actually paints a line on the chart. And they don't start with dashes, and their position is relevant. So things happen in that order. So these instructions are like a little program you're handing to RDgraph, and RDgraph will execute that program. So we're now going to see many, many graphs. All those graphs you're seeing here, they're graphs in PDF format. So if you're ever using graphs in a presentation, you might want to use RRDtool's ability to output its graphs not only as PNG files, but also as PDF files or as SVG files, for that matter. PDF files can be imported into LaTeX, for example, which is the program I'm using here to create these slides. And the advantage of using PDF is that the resolution is much higher and looks much better in presentation than if you use the bitmap version of the charts. So the first instruction you have to know when you're creating a chart is the def instruction, the define instruction, which defines a variable which you can then use to draw a line. And the variable accesses some data out of an RD file. So it's sort of a compressed fetch instruction. So here I'm telling RDgraph that I want data from the file xrd, and I want it from the data source A, and the data should be averaged. So RRDtool graph will use fetch to pull a round-robin archive holding average data. The resolution and the time range, that will be supplied automatically because that can be calculated from the information about the point in time of the graph and the resolution of the graph. So RRDtool will always try to get data which is the same resolution as the number of pixels required to draw the graph. So each pixel ideally should represent one data point in the round-robin archive. Obviously, often there are more than one data point for one pixel, but it might also be that there's less. So here, in this case, there's fewer data points than pixels, and therefore you get that staircase representation. As you can see, the numbers here on the side, there's something funny with those numbers. It's not very... Okay, let's say this graph represents the traffic on your router. Would that be a good graph? It doesn't start at 0, which is okay for newspapers. But if you're interested in representing the amount of traffic transported by your circuit, then having a chart which doesn't start at 0 is not very good. Okay, this guy, especially because it's almost starting at 0, so it's pointless. But if you want to represent the actual amount of data, then you should start at 0 so that it's visible. If you're interested in representing the change of the data, the Dow Jones changed 0.5% yesterday, and you want a chart of that, then you shouldn't start at 0, because otherwise you wouldn't see anything. It'd just be flat. But if you want to show that the Dow Jones is now at 15,000 and it has been at 10,000 a year ago, then maybe you should start your chart at 0 to actually represent that huge amount of change. And you can easily do that by telling RRDtool that the lower limit of your chart is 0. And then it'll adjust to 0. As you can see here, the numbers on the vertical axis of the chart, they're very sensible numbers. RRDtool tries very hard to come up with sensible numbers on those lines. If you look at other charting tools, you'll notice that they don't care. They just say, okay, that chart needs 10 lines vertically, and then you end up with some fancy random numbers. Well, not random, but some numbers just sitting there, and they don't make lots of sense. And so RRDtool tries to figure out a scaling so that you end up with good numbers. Now, your mileage may vary, but that's just the kind of numbers I like. And so that's what shows up. And you can do that regardless at what scale you're operating. RRDtool graph gives you a lot of options to tune it and to take tight control of how the presentation of your graph is. But if you don't tune it and if you don't take control, then it'll try to do something sensible. And that's why, in this case, I didn't specify anything except for the lower limit, and obviously the instructions to pick the data and draw the lines, but I didn't tell it how it should do any of the scaling. That happens automatically. If you're not so happy with those staircase lines, there's an option called slope mode, which causes the staircases to be sort of filed off a little. Still staircases, but they look a little nicer. RRDtool 1.0 used a different graphing library, which wasn't capable of doing anti-aliasing. It used the GD library, and therefore graphs created with RRDtool 1.0, they had a different look than the current graphs. And if you were really fond of that look, with RRDtool 1.4, there's this option, graph render mode mono, which causes the lines in the graph to go back to that blocky 90s way of presentation. Also with the font, if you want to make the font look like in an 80s computer game, you can do that by switching font render mode to mono. Obviously, that only affects the PNG version of the charts. If you create PDF versions, they're vectorized anyway, so there'll be no blockiness to them in any way. The instruction for drawing lines takes a number after the line instruction, and that number can be an integer, it can also be a floating point number, and it represents the width of the line being drawn. So here I'm drawing two lines, and the second line has a width of 4 associated with it, and therefore it'll be 4 pixels wide, looking a little bit heavier. Now, as you're drawing graphs, or as you're designing graphs, even though you may be a very technical person, there is a little bit of design coming into play, and you have to consider the people who are going to look at that graph and how it affects them. And there are also very simple practical things, like if you pick a bright color like yellow and a darker one, then if they're both 1 pixel wide, the yellow color will tend to sort of disappear into the background. So while you might not want to make it 4 pixels wide, you might want to make the yellow color a little bit wider than the darker color in order to cause it to have the same optical weight. You can also use line widths which are less than 1. So you could have a line with a width of 0.8. And because of the anti-aliasing, it would then become a little lighter, causing the viewer to get the impression that that line actually is thinner than 1 pixel. RRDtool 1.4 also introduces the concept of named arguments. So you have these line instructions, and then after the name of the data source and the color of the line and an additional argument for specifying a caption for the line, you can give further arguments specifying, like dashing, for example, here. So here I'm specifying that the line shouldn't be a straight line, it should be interrupted so that it's dashed. Now, these dashes I chose here, they're really ugly. It's just to show you what you can do to a graph. But if you picked a short dashing interval and you were creating graphs for print, for example, then that might be a way to actually show people that those are two different things. The def instruction also supports named arguments. And one of those named arguments is the step argument. By specifying the step, you can instruct RRDtool to not try to pick data at the resolution of the graph, but rather at some lower resolution. And here I'm telling it to pick data at a 1,800 second interval. What it'll actually do here is it'll re-sample the data at 1,800 seconds. Is it too low? You can't actually see the bottom of the screen in the back?
Yeah, I can't see that. I'm fine. I just look.
But you manage? Okay. You can load the presentation onto your screen as well.
I didn't catch the URL.
Okay, let me show the URL again. Okay.
Yeah.
Good. Or you could specify the start of the data. So normally, RRDtool will fetch data which covers the graph, which makes sense, right? Because that's the data you need. Except there are also other instructions which let you shift data around in time, as we will see. So here, I'm telling RRDtool that I want to fetch data, but starting at some other point in time. You can also define what method RRDtool should use to reduce the data to the required step interval. So here I'm specifying that it should pick the minimal value at a 1,800 second interval. So it's fetching this range of data, and then it picks the minimal interval, the minimal value, and paints that. And the green guy does the same, except that it picks the max value. You can see the green and the red lines. They represent that different instruction. Apart from line, there is also a command called area, which lets you paint an area in the graph. Coming back to that idea of showing off the amount of traffic your router has transported, it might be sensible to represent that as an area and not as a line, because traffic is something huge. And so having an area represent that traffic would maybe convey that information more efficiently than just drawing a line aerially up somewhere. Okay, let's stop here. You have a 15-minute break. I guess there are refreshments in the coffee chaos bar thing. We'll start again at 10:47.